Hi everyone, welcome to our video presentation. In this video, we are sharing our project which is an experimental investigation of wireless power transfer using electromagnetic induction. In this video, we're going to show you exactly how we transfer power without any wires, the components we use and what we found. First, let's meet the team. Our group is Group 37 and here are the team members who work on this project. I, myself, VENGEDESH and my teammates are Muhammad DANISH, KEERTHIGA YOGENDRAN, HAZIQ DANIAL and SAVVIER MELSON. Now, let's introduce about wireless power transfer. First of all, what is wireless power transfer? Wireless power transfer is a method of transferring electrical energy from one place to another without using physical wires. In this project, power is transferred using electromagnetic induction. When current flows through the transmitter coil, it creates a magnetic field. This magnetic field is then received by another coil called the receiver coil, and electrical energy is induced in it. We chose this project because wireless power transfer is a useful and modern technology. It is used in many real-life applications such as wireless phone chargers, electric toothbrushes, medical implants, and electric vehicle charging systems. In this project also helps us understand how electromagnetic induction works in a practical way. Besides that, it is interesting because we can show that electricity can be transferred without direct wire connection. Now, let's look at the components we use to build our circuit. Now, let's talk about the components we use to make this happen. First, we have the 2N2222A NPN transistor. This is a fast switching transistor that we use to create high frequency oscillation in the circuit. Next is our power source, a 9V battery, which provides a stable DC supply to the transmitter. For the coils, we use 23-turn copper wire. The animal insulation is really important here because it lets us wind the coils tightly without causing a short circuit, which helps the magnetic coupling work better. Finally, we use a red LED. We chose this because it has a low forward voltage of about 2.1 volts, making it very easy to light up using the wireless power we induce.
For the procedure, we prepare the coils 20 turns of the transmitter, 34 for the receiver. Remove the enamel from the wire ends using the sandpaper. For the transmitter, connect a 9V battery, a 2N2222A transistor and the transmitter coil. Double check our connection. For the receiver, simply connect the receiver coil directly to the red LED. We must mind the testing. We will power the transmitter and bring the receiver coil close. The LED should light up. Now, when we move them apart, we will see brightness drop as distance increases. Why? Because magnetic coupling weakens how it works. The battery powers the transistor, which switches DC into high frequency current. This flows through the transmitter coil, creating a changing magnetic field thanks to Ampere's law. The receiver coil picks up this changing field, and Faraday's law induces a voltage which lights the LED. That's the electromagnetic induction in action. Keep in mind, power drop with distance, alignment matters and the transistor will heat up.
For this part of the experiment, I'm going to explain whether the wireless power transfer system was successful or not. Based on the observation of the video on the last slide, the experiment was successful because electrical energy was transferred from the transmitter coil to the receiver coil without using any direct wire connection. When the transmitter circuit was switched on, current flowed through the transmitter coil and produced a changing magnetic field around it. This changing magnetic field passed through the receiver coil and induced voltage in the coil due to electromagnetic induction. As a result, the connected load was able to operate. This shows that power was successfully transferred wirelessly from one coil to another. However, the performance of the system depended on the distance and alignment between the two coils. When the coils were placed close to each other and properly aligned, the output was stronger. But when the distance was increased or the coils were not aligned properly, the output became weaker. Therefore, we can conclude that the experiment was successful in demonstrating wireless power transfer using electromagnetic induction. At the same time, the experiment also shows the coil distance, coil alignment, and energy losses effect, the efficiency of the system. That's all from me.
In conclusion, this project successfully demonstrated wireless power transfer using electromagnetic induction. The experiment showed that electrical energy can be transferred without direct wire connections. We also found that the distance and alignment between the transmitter and receiver coils significantly affect the efficiency of power transfer. Overall, the project achieved its objectives and proved the concept of wireless power transfer. That's all from us. Thank you.